Hey everyone, thanks for coming. Well, it's not like it came from anywhere, but anyhow, thanks for tuning into my talk. Today, I will discuss a case study with you, which is based on one or two of my clients. I won't name any names, but I think some of the things I'll be talking about will sound familiar to a lot of you. And for the rest, I hope you have a vivid imagination. First things first, who even am I? My name is Lian, and I'm an engineering manager at Container Solutions. We are a consultancy focused on programmable infrastructure, cloud-native transformations, and so on. I've been in tech for a decade, about a decade, first as back-end dev, then front-end, then full stack, then DevOps. I also dabbled in data engineering, data science for a while, and I moved to Amsterdam about 3 years ago to join CS. So what kind of clients am I speaking about? As an engineer, I've had experiences with small startups with just like a handful of people up and to really big global orgs with around 800 engineers. Since I started working with CS, I also worked with huge enterprises in highly regulated sectors, like the one that I will introduce. And this company that I'm going to be speaking about doesn't exist. It is a stand-in, an amalgamation of a couple of similar experiences that I've made at similar clients, and they just act kind of as a stand-in for the problems I've encountered and how we solve them. So let's jump right in. This client is called MoneyBank, and I guess you can kind of already maybe guess what kind of sector this organization operates in. So MoneyBank is a huge enterprise with a tech department of around 200 engineers that includes software engineering, operations, and office IT. Also, as is typical with enterprises, there are clear hierarchies and to some extent clear roles and responsibilities. I say to some extent because these roles and responsibilities are not always clear to everyone. There's a C-level, there's multiple layers of middle management, just as you would probably know it from bigger enterprises. And finally, as you might have guessed, MoneyBank is operating in a highly regulated sector in fintech. This is a sector that we've seen explode in the past couple of years, so there's definitely some companies that you could imagine now. Within the engineering department, so now I'm excluding office IT from that, there are product teams which develop individual products and features, for example, the software used by tellers or online banking software used by clients. There are service teams which provide internal services for the product teams. Most notably, this would include operations as they provide the service and platforms to run the products on. And finally, we have specialized teams. They act as facilitators and internal consultants, but they do not directly contribute to the product pipeline. So the security team, which provides best practices and guidelines to the developers, are an example of such a team. There's one team that's kind of doesn't entirely fit, which is QA. QA is somewhere in between a service and a specialized team, because on one hand, they provide devs with assurance of quality, kind of QA as a service, but they also develop best practices, which they then share with all the devs. So when our team first met with MoneyBank, their biggest challenge was that their delivery was slow. And they identified the issue already, which was that there were a lot of manual steps involved. So I already mentioned QA, that they are somewhat of a service team, somewhat not. So they provided, as I said, QA as a service. And the consequences of this was that what QA was doing was a complete black box to anyone outside. No one really knew how they were testing and how they were approving changes. They had their own way of doing things. They had their own, and they were completely independent. And the handovers to and from QA were often laborious and had to be done manually. Spinning up test environments for QA also had to be done manually, or at least the individual scripts had to be modified and then triggered manually. And also the test environment belonged to QA, so no developer was allowed to do anything on it. And this was also not just for a test, but also staging required some manual work to get ready because, for example, some data needed to be loaded into staging. And that was done manually. And finally, because of compliance, the final check before things go to production had to be done manually by all the major stakeholders in a big meeting. So we spoke to their developers, we spoke to their managers, we spoke to the operations team for about a week. And after we found we kind of understood their problems, at least on a surface level, we went in and started to throw in some suggestions. So for QA, we figured that we needed to get them to automate all their tests. There was no way around it. They needed to standardize how to approve and how to do the handovers, because there was no way around reducing cognitive load and workload in any other way. To quickly spin up test environments, we suggested to move to container orchestration, i.e. Kubernetes, but they chose to host their own OpenShift clusters in-house. So this way they could guarantee that all data and traffic was kept on-premise in accordance to European data protection laws. And finally, to ease auditing and to give everyone a security blanket, we suggested to go with GitOps as the CICD flavor. So we came to an agreement. They really liked our suggestions and hired us to help move their services to OpenShift with the new GitOps platform that we were supposed to help build. To understand the changes that needed to be made, let's consider the starting position first. So this is the situation that we encountered when we first spoke to MoneyBank. A release or change would always start with a product owner requesting a new feature. They would speak directly to the devs or open a ticket in the ticketing system. The devs would pick up that request, implement it, and do some local rudimentary testing. Some services had unit tests, some didn't. Next, the devs would merge or cherry pick all changes into one release branch, and this would be the release package. The release manager, represented by the third lane here, is a specific role that is sometimes taken over by the dev team lead or sometimes by the PO. That really depended on the structure of the team. This release manager will build the artifacts and then deploy them to the development environment, where the devs then can do some integration tests between the services. And finally, when everyone was happy, the release manager would approve the changes. Once that is done, they would inform QA. QA would then deploy the changes to their test environment, again, in their own way, run their tests, and then approve the changes. When QA is done, they inform the release manager, so the release manager now can trigger the deployment to staging, and then inform the PO to do their own tests and give final approval. Finally, the entire changelog, including all references to commit hashes, artifacts, and so on, are sent to the operations team, who would then deploy the changes to production. Sometimes things go wrong here, because despite all the rigorous testing, production, staging, and test fundamentally differed from each other in the way that they were maintained and provisioned, mainly because of convenience. Let's take a look at this middle lane first. These are the things that the release manager does. The stuff that's blue here is already in itself automated, but required some manual triggering. The test and approval step is somewhat automated for some services, not for others. And the deployment to staging is kind of also in itself automated, but because the environment, the stage environment is a shared one, a release manager can use an automated process to deploy, but they still need to do some legwork to update some configuration here and there and make sure that all services are still talking to each other. So the first thing we try to do is to automate the entire middle lane, so the role of the release manager could be taken over completely by the system. We would start again with the PO requesting a feature, with devs implementing and testing it. But now any merge to the release branch would trigger a build step. And this would then start the building of a Docker container. Once the build was done, a deployment to the development environment was automatically triggered through GitOps. So we would create a pull request to our config repository, which would automatically be merged, and then we would run our automated tests. If all tests passed, QA would be informed that a new release was ready to be tested. They would take over, go with the usual flow of deploying, testing, and approving. And then to give their approval, all they had to do was to approve a pull request that had also been automatically created to deploy the changes to staging. And that would then happen automatically again through GitOps. Once deployed, the PO would receive, again, automatically a notification that the changes are now ready to be tested on staging, and the rest of the process stayed the same. What's great about this is that we started to abstract the infrastructure in such a way that automated deployments through the GitOps platform were technically possible for all environments. But still within this process, some of the deployments were done manually. So let's take a look at the architecture. Everything starts with the application repository. From there, we have a Jenkins pipeline that does two things. Well, it does more than two things. It builds the artifacts. So it builds one or more artifacts and pushes them into an artifact repository. In this case, we use SonarQube Nexus that lived outside of our clusters. After all the artifacts were in place, we then would submit a change to the config repository, starting with dev. So we had one repository for each environment for each namespace or business unit. This repository would trigger an Argo CD instance to deploy the resources onto the cluster, and we had this for each cluster. So we had one Argo CD instance for each cluster. And this Argo CD would keep monitoring the repository and deploy automatically if any changes were detected on the main branch. And technically, this would work for all environments up until production. The actual setup was a bit more complex than this, but it should hopefully give you an idea how the flow kind of looked like. Now, the thing is, when we look again at this delivery flow, we can see that the deployment to prod is still being done manually by the ops team. The reason why it was done manually here was because the ops team were the owners of the most sacred place, the prod environment. So they were personally responsible for what happened there. So I've heard people say, well, you have to sign it with your blood 3 times before you let anything go to production. To address this, we kind of did the same thing as we did with staging. We automatically created a pull request with the changes between prod and staging. And the ops team simply needed to approve that pull request. And when they did and merged it, it would automatically trigger a deployment through Argo CD in the same way as we did it for dev and staging. This took a lot of time and responsibility off the plate of the ops team. And interestingly enough, we ran an experiment and we detected less errors in prod instead of more, which had always been management's biggest concern. So next, we took a look at the QA, which owned their own infrastructure and had their own development culture, structure, and way of doing things. That was something that had to cause a lot of friction between the product teams and QA. I already talked about this a little bit. QA didn't really belong in the normal structure of the engineering team. They were always somewhere kind of in between, but still they were very crucial to the delivery process. After a lot of discussions and designs, we figured that the ideal solution would actually be a truly radical change. So we first had to get buy-in from the customers, and they said, well, a radical change is fine as long as it pays for itself in the end. So we suggested it. We wanted to eliminate QA completely as a team and also as its own lane in this process. So how would this work? Obviously, we were not suggesting to eliminate QA quality assurance entirely, but instead we suggested to embed it into the development teams. So the development teams would be truly cross-functional. So the team member responsible for QA would write the test suites already during implementation and still keep in touch with the former QAs through a community of practice. But now the way that they worked was completely transparent to everyone, and it was standardized across the entire organization. So in this process, everything stays the same up until when the devs are done with their preliminary tests on the development environment. The test environment now belongs to the dev teams, which meant that they were finally able to do away with all the extra stuff for QA and could instead standardize their deployment flow, or we could standardize the deployment flow throughout all the environments. The tests were run and approved automatically, and plus, because the dev teams own everything here now, they were in full control of the process. And once the automated tests passed, it would automatically trigger the deployment to staging, and the rest of the flow stays the same. At this point, we were with MoneyBank for about a year. Development speed did pick up, and developers were much more productive now that they could focus on development instead of merging strategies. But plus, since everyone could deploy at any time, and they did, confidence in the system grew. You use it often enough, and it doesn't fail as often. You believe and you trust more and more in it. But there was one thing still bugging the engineers, and they had united and picked someone new to blame: the slow deployment to prod. So everything was super fast, but in front of prod, changes would pile up. Why? Let's take a look. So it's true that some of these steps are still manual in this process. There are these red ones, which will never be automated though, because they are by nature manual tasks, at least for now, at least before the robot uprising when AI takes over. But if you look at these other steps, I think there is still something we can do about it. One of the main reasons why the PO and ops still need to do manual approvals is because they need to sync with the board and higher level stakeholders about business intention. Do we need to communicate a downtime? What are our risks here? Do we need to prepare for maybe an entire breakdown of the service? On the surface, these also seemed like steps that are in their nature manual, but we still felt that there was something missing. There was a lot of cognitive load and overhead we felt was not necessary here. And in one of our sprint reviews, one of our stakeholders, who was a fairly critical person, kept pointing out, a pull request is just not enough. Business people cannot read that. And I wanted to make a joke and replied kind of cheekily, but they can read Jira tickets, right? So we chuckled, but then we looked at each other like, are you thinking what I'm thinking? And thus a pattern was born. So I'm pretty sure that there were other smarter people that came up with this pattern before me, but I came up with a catchy name too. Hooray, the idea of ReleaseOps was born. It's not a new idea. The whole point of this is to align what a release means for the business with what a release means for the platform. So let's take a look. I've moved some of the swim lanes around to better illustrate what happened. So take a look at the second swim lane here. This is our newly introduced shiny ReleaseOps automation layer. And all it does is represent the state of a Jira issue. So we would start again with the PO requesting a feature, but this time they don't message the devs about it. They instead create a Jira issue outlining the feature request, acceptance criteria, and the release gets an identifiable ID, the issue ID. The devs are automatically informed and implement the request. They add comments when they make design decisions explaining the reasoning. And when they're done, they move the issue to the next status, which is in deployment. That automatically merges their feature branch into the release branch. So we had to only allow development on the branches that had been created through the issue. And those issues were linked to higher level releases. Some of you have possibly been moaning a bit or snickering a bit about Bitbucket and Jira, and I get why. But honestly, Atlassian delivers solid products and they integrate very well with each other. So why not use it? So from there, we can now go to the below swim lane as soon as we merge the release branch to main, which triggers the entire process as before, until we get to the point when the changes are deployed to staging. So instead of notifying the PO directly, our pipeline now sets the issue status to in review and then assigns the issue to the PO. This only worked with us keeping a mapping of the service and the respective PO on the cluster as a config map, and our pipeline could grab this information and send it to Jira. The PO knows as soon as they get the notification that they can now test the changes that were listed in this Jira issue on staging and give their approval in the ticket. Now, all issues that are in review automatically trigger the ops team. They are the people who own the approved column. So they are the only ones who can truly move a ticket to the approved column. And they can only do it if the PO has already approved it. Finally, when a ticket is approved, this would trigger the deployment to prod through the magic of GitOps. So this is what the final design looked like. Everything starts with a Jira issue, which is tied to the application repository through a Jira Bitbucket integration. Once the branch is merged into the main branch, a pipeline is triggered to build and store artifacts into the artifact repository. And at this time, we had now split out a cluster specifically for managing the CICD, managing other clusters. There's also an Argo in there that manages the other Argos. But I don't want to go too deep into this because it would lead us too far astray from the topic at hand. We replaced Jenkins as a pipeline engine with Tekton Pipeline, which at this point had been integrated into OpenShift as OpenShift pipelines. But same as with the Jenkins pipeline before, after pushing our artifacts to Nexus, we would then publish our changes to the config repositories to trigger a deployment. Just as before, we start with dev and we go all the way to prod. Unfortunately, before we had the chance to fully implement our vision, MoneyBank froze their budget for external consultants. This was at the beginning of the pandemic. So organizations try to keep their money tight, and R&D, is often the first thing to be cut. We were able to build a integration of Jira and Bitbucket before we left as a POC. And from what I hear, they kept with the general idea, but made a couple of technical changes. So we were with MoneyBank for a total of 2 years, and we transformed them from an organization that went from using Docker Swarm and deploying maybe once every 7 to 14 days to OpenShift and deploying daily. So I want to make one more point with this tweet from Kelsey Hightower. He says, I am convinced the majority of people managing infrastructure just want a platform as a service. The only requirement, it has to be built by them. I think there's a lot of truth in that. And since I left MoneyBank, I've seen the rise of the internal developer platform. And I think that is a great pattern. I think it makes a lot of sense. You should always, rather than build something yourself, use something that's already there by people who specifically deal in building this particular thing. But if you need something, custom for yourself, then the best way to do it was to build a platform yourself. And I think what I talked about today, ReleaseOps, that as a pattern is a great addition, is kind of the natural evolution to also invite non-technical stakeholders into the process to make collaboration smoother and easier, and thus also more rewarding. This is the obligatory slide that we're hiring. If you live or want to move to any of these super amazing places, then you can do that. But also, if you live anywhere on Earth, we also now are fully remote. If you're interested, you can talk to me or check out our website. So thank you for listening. And again, if you want to reach out to me to learn anything more about me or my company, here are some ways for you to get in touch. Thank you very much. Hi, can you all hear me? Sure, just let me know if you can't. Cool, thanks, Tracy. So this is interesting because I don't have anyone else to talk to, so I'm just gonna ramble to myself a little bit. Well, thanks everyone. I'm glad you liked it. This is the first time that I actually see my talk kind of played back to me in full, and saw a lot of ticks and things that I'm probably gonna cut out for the next time. So I saw a couple of questions in the chat. There's also a Q&A. I don't know if there's like an order to which I should get to, but the first question I saw was by Paul. Do I understand that the security of production has degenerated to the security of Jira? And I asked Paul to elaborate a bit, because I was not sure if I fully understood what he meant. That as engineers, we build automation which is secure, but if Jira isn't secure, then production isn't secured. Yes, agreed. So for one thing, the SRE or ops team, they have to approve the changes. Oh, Jira is Jira. Okay. Sorry. So there's that, but then of course, if there's a malicious actor who can, how do you say, fake being an ops or SRE person, then yes, that would be an issue. I'm not super sure how big the issue was there, so we were not responsible ourselves for setting up Jira, the ticketing system. That was part of a different department. It was self-hosted though, so I guess there was a pretty small attack surface. But generally, I would agree to that statement. So I hope that answered your question. And then I'm going to go to the Q&A. So there was a question by Joe Tripp. To my mind, the quality of the inbound feature request is crucial to this process. How did the product and engineering orgs get aligned on what was needed to be effective? Okay, cool. So that, if you are asking a question just from like the product management or the product point of view, I don't know if you ever heard about the SAFe framework. So this was kind of I guess, people try to marry waterfall with agile practices or with Scrum. So then out came the SAFe framework, where you basically set, you have 10 weeks PI plannings, and then in the PI you decide on high level objectives, and then those are brought into the teams, and then they do just regular Scrum, so release planning, Scrum planning, and that through these PI plannings, where there were like 300 people or something. They weren't there, but it was a huge kind of greenfield project where before we had this old universe of Docker Swarm mainly, and this new thing was completely new. So we built this new platform with OpenShift, and on top of that was the GitOps, that the platform that we helped build. So yeah, that's how they worked. Was it effective? Probably not. So the next question in the Q&A is by Sudeep. I hope I'm pronouncing that correctly. It would be good to see some demo of how exactly you are doing the release ops in action. Yeah, that would be good, wouldn't it? Unfortunately, since MoneyBank is a huge corporation, a really old one actually, from the fintech sector, nothing we were doing could be open source. We asked a lot of times. So I don't have any code that I can show you right now, but I am planning to work on like a little demo for this, maybe using some open source ticketing system, also maybe using GitHub. So yeah, unfortunately, no demo at the moment, but I'm working on it. Okay, so I'm just going through the Q&A right now because there are more questions coming in. If you have questions, put them in there. It's easier to follow than the chat. This question is by Alicia. In regards to automating PRs, is it compatible with Git Flow? I guess you can make it compatible, but I would not recommend. So I think we had this little conversation, Brian and myself, about release branches, and I guess, yeah, Git Flow, if I understand it correctly, is mainly around creating those release branches, and you can do that. Actually, we had some teams that kind of insisted on doing Git Flow. And it is possible because your or your deployment tool does not necessarily need to listen to, actually, this would be the integration part. So if you have a pipeline, you could just listen to that release branch and then use that as the trigger to deploy your changes. But I think the point of this is to make things easy and visible and readable, and I don't think that Git Flow helps with that. It's kind of the attitude of merge it when you mean it. So you have to be absolutely sure you cannot have this safety blanket other than your tests. So you have to kind of trust in the system, and you don't need release branches because your release is kind of mapped. All the information about this is somewhere else. So that was kind of the idea. But you can make it happen. If it absolutely needs to happen, you can do that. Okay, so the next question is from Paul. What tooling framework did you adopt for your automation? Would you use the same set again? So I'm not sure which part of the automation you exactly mean, but we had Bitbucket as the source repositories, so for the app and the configuration. And then we used basically just HTTP calls mainly. And if we ever needed like a real pipeline in any way, we used Tecton pipelines. So the Tecton pipelines, which is now fully integrated in OpenShift, so not OpenShift pipelines. Other than that, just if we could use some kind of hook to do an HTTP request, we would just do that. And I think I have to end this session in the next minute. So if you have any more questions, feel free to reach out to me on Twitter at Chimney42 or on LinkedIn, Lian Li. And yeah, we can chat some more. I'm definitely up for, I'm also going to hang out in the network section probably. So thanks all for coming. And yeah, I hope that, you learned something or at least could laugh about some stuff. Right. So have a great rest of the conference.